All right, so last time we learned what a molar mass is. It's the mass that you would need to weigh out of a specific material or element, compound, if you wanted to get 1 mole of the material. And we found that we could calculate this mass by using the mass number of the elements on the periodic table. Okay? So the molar mass for carbon dioxide is 44.00. How do we get the molar mass for carbon dioxide? Do you remember?
Carbon dioxide.
Yeah. How do we get the molar mass for carbon dioxide? What do we do to find it?
12 plus 32.
Very good. 12 plus 2 of these 16s, which is 32. Very good. So that's how we get the 44. Now, if the molar mass of carbon dioxide is 44, and remember, that's grams necessary to weigh out 1 molecular unit or 1 mole, what mass of carbon dioxide is found in 1.55 moles? 1.55 moles. So, let's do this one together, and the next one we'll see if you can do for us, or will talk us through it. For this one, we want to write an equal sign. And what goes to the right of the equal sign?
Moles? Grams.
Grams, very good, because it's asking what mass? Grams of carbon dioxide, right? Very good. And what goes up to the top left here?
1.55.
Very
moles.
good. 1.55 moles of carbon dioxide. Excellent. And now, do I have a conversion factor that tells me moles? Because moles goes down here, right? We know that. Moles of carbon dioxide. And then what goes up here?
Grams.
Grams of carbon dioxide. Very good. Do I know how many grams there are in a mole of carbon dioxide?
44.0098.
Good job. We'll just say 44.0 for now. Very good. And that's how many grams there are for 1 mole. So we see that if we take the 1.55 times the 44, it'll tell us how many grams of carbon dioxide are in that many moles. So it's 68.2 grams. Good job. How many moles of carbon dioxide are in 10 grams? If I have 10 grams of carbon dioxide, how many moles are there? What goes to the right of the equal sign this time?
Moles.
Moles. Good. Moles of carbon dioxide. And it's important that we're specific, so we don't just write moles, right? We want to write moles of carbon dioxide. What do we start with the top left?
10 grams.
Good job. 10 grams of carbon dioxide. And then we know has to go down here what?
Grams of carbon dioxide.
Very good. And up here?
Mole.
Very good. Moles of carbon dioxide. All right, so what are my values that go in here?
Um, 44 on the bottom.
Very good. 44 on the bottom.
1.
Very good.
Mole.
1 mole there. So 10 divided by our 44, that should be our answer, which is 0.2 moles. 0.2 moles. Okay, very good. So what we're seeing here is that this information, the amount of grams per mole of material, is a very valuable, and will be throughout the rest of this class and throughout any chemistry career, it's a very valuable conversion factor. And essentially what we're learning is that the units for these numbers, iron 55.847, that's how many grams you need to get 1 mole of that material. All right? So very important conversion factors. All right. What mass in grams of, what's the name of this compound right here? Can you tell me?
Calcium phosphate.
Very good. Calcium phosphate. What mass in grams of calcium phosphate would a 3.2 mole sample have? How would I set this one up?
Draw your line.
Good.
No, the line which goes up and down.
Oh, okay.
Right, mole.
Where?
Very right.
Over here?
Yeah.
Is it? Are we after moles? Sometimes.
No, we're after grams.
Yeah, we're after grams. Grams of what?
Calcium phosphate.
Very good. So I'll write that down here too. Grams of calcium phosphate. Okay, good. Sometimes if you can't tell what you're after, or even if you write it down, a way to double check is to, especially if you have multiple choice like this, is to look and see what units they're providing. Then you know that that's the units you want to have to the right of your equal sign. Very good. What's next?
3.2 mole.
Very good. Of calcium phosphate. Very important to not be lazy and just write 3.2 moles, because that information here helps you know what has to go down here. Okay, good.
Grams of calcium phosphate.
Very good. Now, what numbers do I have?
Moles 1.
Yes. Now, what is this little thing they have here? MM equals 310.17.
Oh. That's how many grams are in a mole?
That's right. That's the molar mass. Very good. So, the 310.2 goes there then. All right. Do you have a calculator then?
Uh-huh.
Let's see if you can get which one of these is the right answer.
Wait, 3.2 times or a plus?
What do you think? What did we say? We multiply everything on top and divide everything on the bottom, right?
$992.
Okay, is that answer on the board somewhere? Or is it none of these?
B.
B, very good. Excellent job. Okay, very good.
Wait,
Now,
go
yeah.
back. How do you know there's a 2 there? It doesn't show that in the question.
This 2 right here? Oh, that 2? I just rounded up to that number. You can use all those numbers if you want to, but we only had 2 significant digits right here. So we just need to have 2 here. So we had 1, 2, 3, 4 significant digits. So I just took the 4 significant digits. You only need to take 1 or 2 more than you start with. So because we only started with 2 here, I just took 4 here. Does that make sense?
Yeah.
Because our answer is only going to have 2 significant digits. Good question. All right. So, stoichiometry. Doesn't that sound like a nice German dish of noodles or something like that? Stoichiometry. Yeah. Well, it's not. It's not even a nice dessert. Stoichiometry is the relationship between the different moles of material in either a chemical formula or a chemical reaction. So, for example, this compound, Na2CO3, what's the name of that compound?
Are you moving?
Yeah, what's the name of this compound right here?
Oh. Sodium. Oh, no, wait. Carbon. Oh, wait, no. No, it's just... Carbonate.
Very good.
Carbonate.
Exactly. Sodium carbonate. Excellent job. All right. So I'm going to show you some what we call stoichiometric relationships between the different materials in sodium carbonate. We can say there are 2 moles of sodium for every mole of sodium carbonate. Can you see how that becomes a conversion factor? I can say 2 moles of sodium for every mole of sodium carbonate. Right?
Yeah.
And I could flip that, so that's 2 conversion factors right there. Here's another one. 1 mole of carbon for every mole of sodium carbonate. You see how we got that one? You could count how many carbons there are. And if you had 1 mole of this material, you'd have 1 mole of carbon in that material. 3 moles of oxygen are in 1 mole of sodium carbonate. Now, some people get bothered by this because they say, wait a second, how can you have 3 moles of something if you only start off with 1 mole of it, right? Well, it's like a hamburger. If I have a mole or a dozen, any number with a name, if I have, let's use a mole, 1 mole of hamburgers, how many moles of buns do I have? There's a top bun
Twice as many.
and a bottom bun. That's right, twice as many. 2 moles of buns. And if each one of these hamburgers has 4 pickles on it, how many moles of pickles?
4.
That's right. How many moles? 4 moles of pickles. So it's okay that I have 3 moles of oxygen within this 1 mole of this material. So make sure that that doesn't bother you too much. there's lots of other stoichiometric relationships that I can make with sodium carbonate or any compound for that matter. Let's see if you can catch this one. How many moles of carbonate ion are there if I have 1 mole of sodium carbonate?
Wait, say that again?
How many moles of carbonate ion, the CO3 ion, CO3 2 minus, how many moles of carbonate ion are there if I have 1 mole of carbonate, sodium carbonate?
You have 1 mole, and you have there.
For every 1 mole of sodium carbonate, I have 1 mole of carbonate. Can you see that? There's just one of these CO3s.
Oh, yeah.
Okay. How many moles of ions do I have if I have 1 mole of sodium carbonate? How many moles of ions? What are the 2 kinds of ions, and how many do I have?
CO.
I have the CO3 2 minus ion, the carbonate ion, and I also have the what ion?
Sodium.
The sodium ion. And I have 2 sodium ions. So for every mole of sodium carbonate, I have 3 moles of ions. Can you see that?
Nope.
That doesn't make sense?
No.
Okay, so let's talk about that a little bit. If I have 1 mole of sodium Na2CO3 carbonate, how many moles of ions do I have? How many moles of ions? Well, each mole of this material is made up of 2 of these sodiums, right? That's what that says, 2 of these sodiums, and 1 of these CO3 2 minuses. So that's a total number of ions, 3. 3 different ions. So how many moles of ions do I have if I have 1 mole of sodium carbonate? I have 3 moles of ions. Can you see that?
Yeah.
Okay. So we can talk about moles of sodium, we can talk about moles of carbon, moles of oxygen, or moles of ions, right? There's lots of different stoichiometric relationships, and that's what we call these. Any relationship that you can talk in terms of moles of one thing per moles of the group or whatever, those are called stoichiometric relationships. Okay? So, let's introduce a couple of other stoichiometric relationships. Here's a chemical reaction. A plus 2B yields 3 C's. All right? So this is a stoichiometric relationship here, too. For every 1A, 1 mole of A that reacts, I need 2 moles of B. Can you see that? What? I can't hear you.
A.
What?
A.
Okay, so this is 1A reacting with 2B.
Oh, yeah, I get that.
So I can say that I react 1 mole of A and it requires 2 moles of B's. Or I could say for every 1 mole of A that I react, I get 3 moles of C. Right? Can you see that?
Yeah.
Yeah? Okay, so here's a question for you. How many moles of C do I get if I put in 2 moles of B?
3.
That's right. The 3 goes here. All right. So for every 3 moles of C that I get out, I need to put in 2 moles of B. So there are stoichiometric statements that you can make for chemical reactions as well. Again, a very, very important concept in chemistry. All right, so can we calculate the number of moles of sodium in 2.53 moles of sodium carbonate? How many moles of sodium in 2.53 moles of sodium carbonate? What goes to the right of our equal sign?
Moles.
Moles of what?
Sodium.
Moles of sodium. That's right. Well, just moles of sodium because they're saying to calculate the number of moles of sodium. All right, what goes up to the top left?
2.53 moles.
Moles of what?
Sodium.
Sodium carbonate?
Yeah.
What's the chemical formula for sodium carbonate?
NaCO.
Any what?
CO.
Okay, so CO. What's the carbonate ion look like?
That's what it was. CO. Carbonate. Where is it? Yeah, it is CO.
CO. Carbonate right here? CO3?
Yeah.
CO3, right?
Yeah, CO3.
CO3, okay. So, is that the chemical formula for sodium carbonate, NaCO3?
Yes.
Okay. So, what goes down here then? Is that moles of sodium carbonate, NaCO3?
Yeah.
All right. And then, how many moles of sodium are in a mole of sodium carbonate?
Oh. There is 22. Right. 23.
That is grams of sodium per mole of sodium, or per gram. That's grams of sodium per mole of sodium, right? There's 23 grams of sodium for every 1 mole of sodium.
1 mole. There's 1 mole.
1 mole of sodium for every 1 mole of sodium carbonate, like that?
Yeah.
Okay, so what would our answer be then? We're there because we have moles of sodium.
2.53 moles.
2.53. Okay, let's see how we did. Uh-oh, they got 5.06. What did we do wrong?
Wait, why is it 2? There's only 1 Na. Oh, wait, what's the charge? Oh, yeah, you need 2. You need 2 because the charge.
That's right, because the carbonate has a 2- charge. All right, so we see that it's critical that we know the chemical formula for the compound that they're asking. If we don't know, we're not going to be able to know the stoichiometric relationship there. All right, very good. Calculate the number of atoms of sodium in 2.53 moles of sodium carbonate. What goes to the right of the equal sign now?
Atoms of sodium.
Very good. Atoms of sodium. Okay, what are we going to start with?
2.53 moles of sodium carbonate.
Okay, 2.53 moles of, that's Na2CO3. I know now, right?
Yep.
Okay. So, I know that moles of sodium carbonate goes down here.
And moles of atoms?
If we go to moles of sodium, then we can know how many atoms of sodium are in a mole of sodium. Because remember what that is? It's that long number, right? 6.02 times 10 to the 23rd. That's how many whatevers there are in a mole of whatevers, right? So if I have a mole of sodium, there's 6.02 times 10 to the 23rd atoms of sodium. Okay, so what's the numbers that go here now?
Oh. 1 and 2.
1 and 2, 1 on top? Or what?
No, 2 on top, 1 on bottom.
Okay, 2 on top, 1 on the bottom, and anything go here? Is that just 1 mole?
Yeah.
Okay. So, we have to learn how to type this into our calculator now.
Where's 10 times 10?
Yeah, let me show you where it's at.
I've played around and I've pressed it before, but now I can't find it when I'm looking for it.
So here's what we do. If I want to type in 6.02 times 10 to the 23, I type in 6.02, and then see this comma right here? Above that comma in blue is EE. And to get there, I have to type the second, and then that. And I'm going to start over because I like to go like this. 6.02 times 10 to the. So that reminds me that what I've typed there is the 10 to the value. And then I just type in 23. And then I can push enter, and now it says 6.02 times 10 to the 23. That E means times 10 to the. And then I just multiply it by the 2 and by the 2.53, and then it gives me my answer. Okay? 3.05 times 10 to the 24th. What is that? What did we just solve? We just solved what?
The atoms, how many atoms of sodium?
In 2.53 moles of sodium carbonate. Very good. 3.05 times 10 to the 24th. Excellent. Okay, here it is. Let's see if you can get this one. How many atoms of iron are in a 15-gram sample of iron 3 oxide? I'll be your scribe. You tell me what to write.
There. So we are gonna write the equal sign, right?
Yes, an equal sign.
Grams to the right of it.
To the right of the equal sign?
Yeah.
What is the question asking? How many what?
sodium.
Read it.
How many atoms of iron are in a 15-gram sample? How many atoms? So atoms.
Atoms of what?
15
Atoms
of iron.
of iron. Very good. So, what do I start with over here?
15.0 grams of iron.
15.0 grams of iron. Is that what I have?
Yeah.
I have 15 grams of iron 3 oxide, right?
3 oxide.
Uh-oh, what's the chemical of iron 3 oxide? What's the chemical formula for iron 3 oxide?
Fe.
Fe. Just like that? Or do I have to have more than one iron or more than one oxide?
3 oxides.
3 oxygens?
Yes.
How many irons?
1.
1, just like that, FeO3?
Yes.
Okay, what is the 3 telling me? What's that 3 telling me?
That there's 3 irons in each oxygen.
No, remember the number tells me the charge, right? Because iron is a transition metal and we have to have a little extra help. So it's telling us the charge on the iron. So if I drew the ions up here, the iron ion has what kind of a charge?
Wait. It has a negative charge.
No.
Positive charge, yeah.
What number is it? Positive what?
3.
Positive 3. And the oxide ion, what's its charge?
It is negative.
Negative what?
3.
Look at where it's at on the periodic table. You see where it's at? It's number 8.
Yeah, that's 2 away.
Yes, so it needs 2 electrons. 2 electrons, so it's minus 2 charge. Did you say minus 2?
Yeah, no, the first time it said 3.
Okay. But can you see why it's 2 away? And so it needs two electrons?
Yeah, I just thought for a second that you counted oxygen, then you went 1, 2, 3.
That happens to me too. And when that happens, I think about the number 8 here, 9, and 10. And I remember that the atoms want to have this number of electrons. So if it already has 8, it needs 2 more to get to the 10. Does that make sense?
Yeah.
Okay, now that we have these numbers, we have to use that rule, right? To know how many irons there's supposed to be for every oxygen, right?
Mm-hmm.
Can you see that?
Yep.
All right. Critical to know because Fe2O3, if we didn't know how many grams of Fe2, if we didn't know what the chemical formula was, then we wouldn't be able to move forward. So we wrote grams of iron 3 oxide down here, Fe2O3, and we want to go to moles so that we can get moles of iron and convert that to atoms of iron. So if we start with grams of iron oxide, what are we going to put up here?
Moles.
Moles. Moles of Fe2O3. Then we can go from moles of Fe2O3 to what? Moles of what?
Atoms.
To moles of iron first. And then moles of iron to what? Yes. Atoms of iron. Okay, help me fill in these numbers now. What numbers go here? What's the top number? What's the bottom number?
1 mole
Mm-hmm.
of Fe. Yeah. And then 159.69.
69, is that okay?
69, sure.
Sure, I have 1, 2, 3, 4, 5 significant digits here and 3 there, so that should be plenty. Okay, what goes here? What numbers go here?
The bottom one is 1. Wait, no.
Uh-huh.
And then 2.
That's right. 2 moles of iron for every mole of that stuff. All right, what goes here?
1 mole of iron equals atoms. A lot.
Yeah, 6.02 times 10 to the 23rd.
Times 10 to the 23rd.
That's called Avogadro's number. Avogadro's number. So, 6.02 times 10 to the 23rd times 2 times 15 divided by 159.69. 1.13 times 10 to the 23rd. Is that number on one of our options?
Yes.
Which one is it?
A.
Hey, very good. Excellent job. You did a good job today. Talk to you later. Bye.
Bye.